So problem number one, you're solving for x and for y. X is can be best done using what's called the side splitter rule. So we could take these pair of sides here and set up a proportion where x goes to 20 and 10 goes to 18. When we did these problems in class in chapter 3, what we found was that the ratio between the sides, those pieces were the same. You can also go across and set the ratio of x to 10 and 20 to 18, and it will be the same. You'll get the same answer. So cross multiply, you get 18x equals 200, and then divide by the 18, and you'll get 11.1 repeating. So 218 is 109th, 11.19, or 11.1 repeating. The second problem, one of the biggest mistakes I noticed, a lot of students use the same ratio, and the first problem is based on pieces, the second problem is based on the entire triangle. So the small triangle AC is 10, and we're looking for BC, which is Y. And the big triangle, AE is 28, DE is 12, and now AD is 31.1 repeating, or 31 in the ninth. You add in the 11.1 repeating plus the 20. So for this problem, we don't need this number. We put our ratio together with the 10 and the 28, and the y and the 12 for a proportion. So 10 to 28 is equal to y to 12. And cross multiply and solve for y, so y should come out to be approximately 4.286. Any questions? Two different setups. One's a side splitter, the other is they're using the full lengths. And the second problem, the comment I made earlier is that the most common mistake was that a lot of you use the 100-degree angle. So this one actually, we have a pair of a side to an angle, which tells me this is a sine, law of sines problem. So sine of 68 degrees over 71 is equal to, now the x goes to its opposite angle, which is not marked. So we figured that one out, that would be 12 degrees. So sine 12 degrees over x. So cross multiply, get rid of the ratios, and then divide by the sine of 68 degrees. You get x by itself. So x comes out to be approximately 15.921. Make sure you are pairing up the side with its opposite angle, not the angle that happens to be next to it, or closer to it. So any questions on the first two? How many of you got it right this time, but no, you missed the first time? Did my comment help, like 100? That was by far the most common mistake. Now, problem 3 was missed a lot. And I drew the pictures on your test quite frequently. It says I have a 50-degree angle, a 30-degree angle, and the question that is being posed here is Wally right? And a lot of you missed this one, said that angle side angle and angle side are the same thing. And so if I put the side here, here, or here, tell me how I place those two triangles on top of each other so that the three numbers match up. Can't. It's impossible. Angle side angle and angle side aren't the same thing. There's no way to match up the information unless, even if the numbers are the same, you got to be careful. But the numbers, I mean, the triangles isosceles, that may be a different case, but in this case here, with the triangles being scaling, the answer is no. The triangles are going to be different. There's no way we can superimpose one triangle on top of the other to match the numbers up. It's just not possible. All right, problem 4. The correct answer is 46. A lot of you said 18, and that actually is the value of x, but it asked you to find c. So you had to actually substitute the answer of 18 in. So in the triangle, going back to chapter 1, we talk about the fact that in an isosceles triangle we have two equal sides. So AB and AC are equal. And then we talked about later that there are also two equal angles. If I would draw in a line of symmetry, make sure I got that one right, AB and, oh, that's one more. Then try that again. Oh, it's the wrong side. So we have ABC, AB and BC are equal. So that means the line of symmetry is here. So that means angle A and angle C are the two equal angles. Any questions on that? So that means in setting this equation up, three angles of a triangle at the 180 degrees. So that means I'm going to be using the 2x plus 10 twice. Once for A and once for C. So it becomes 2x plus 10 plus another 2x plus 10, or you could have doubled it and made it 4x plus 20, plus the 6x minus 20, and that's going to equal 180 degrees because the three angles of a triangle, the sum rule we're going to use in chapter 2 is 180. Combining like terms, we get 10x plus 0 equals 180. Divide by 10, so x is 18. But they're not asking for x here, they're asking for angle C. So angle C and angle A are the same expression. So angle C is equal to x plus 10. Replace x with 18. And simplify, so the measurement of angle C is 46 degrees. Questions? How many of you got right this time? This is the first one. Did I say a mistake? All right, so in problem 5A, we're asking to identify the angles. This is a pair of vertical angles. So when two lines intersect each other and the angles are opposite each other, they're called verticals. In problem B, the two angles are 7 and 2. Quite a few of you guys said none. But none of these work. But if I have parallel lines cut by transversal, the angles are either what or what. So any two angles from a pair of parallel lines cut by transversal, the two angles will either be what or what. Supplementary or not corresponding. Not all angles are corresponding, equal. The angles are either the same numbers or they're supplementary. There's only two choices here. So in this problem here, angle 7 and 2, angle 7 would actually go right there. Angle 7 and 4 are corresponding angles. So angles 7 and 2 are supplementary. They're going to have 180 degrees. There is no special name for 7 and 2. They're not alternans. They're not same sides. They're not corresponding. They're not verticals. We don't have any special names, but they're still supplementary because there's only two angle possibilities for any pair of angles. I'm sorry, any two lines that are parallel cut by transversal. They're either equal or supplementary. Question B: why is supplementary and not none of these? That's a popular answer. All right, problem 6. The biggest thing I saw in 6 was just be careful of your assumptions. For example, AX and N, I'm going to call this T. Some of you said I, it didn't matter. I accept whatever letter you put there. A lot of you assumed that AX and NT were parallel. But they're not parallel. So be careful of your assumptions. Because of that, the only thing else that we can mark are the two angles at M, the vertical angles. And that does give us a third piece of information, and the triangles are showing the same pattern. So the only answer that works here is angle, side, not angle, side, angle. So some of you marked X and N, for example, but there's no parallel line marks. So max would be what, MT, N, by angle, side. So this is like a rotation in terms of the top triangle being rotated around the bottom. The second one, they're not congruent because the information doesn't match up. There's no way to get this side here on top of that side. It's not possible. They're different places. Triangle on the left is angle, angle, side. The triangle on the right is angle, side, angle. They're showing different patterns. Problem B probably was the most missed of the 5. A lot of you assumed that the TE was perpendicular to JN, but there's no right angle marks there. So, I mean, the triangle could be drawn this way. And if I drew it that way, you would probably never say that those are right triangles, right? So these aren't my problem, these are from the book. They're doing this intentionally to get you to understand what's really true and what are you assuming. Don't assume that the angles are right angles unless they're marked right angles, unless you can prove that they're really perpendicular. Sometimes you can do that, but in this case, cannot. So with that said, the only thing I can mark that in addition to that that's equal is TE. And both triangles are showing side-side angle. But side-side angle only works if TJ is longer, if TJ and TN is longer than TE. Are they? So that's asking the question. So we don't have numbers. Long side, short side angles are issue. And we got to be real careful because, again, the example I gave you was if that segment was over here, for example, those triangles clearly are not the same triangle. So just be careful of that assumption. And for side-side angle, having numbers or Pythagorean theorem really is helpful. So this is not congruent. This one has parallels. So that means angle U and angle W are the same. Alternate interiors. Angle T and angle V are the same, alternate interiors. You could also mark the angles at X, those vertical angles. So you could have said angle, angle, side. You could have said angle, side, angle. Any of those would have worked here. Trying to see if there's any others. I guess there aren't two. There's a rotation. You get the angles to match up. So TUX would be what? V, W, X. The last one, they do share QS, and this time the angles are marked. So now I know that I can use hypotenuse leg. Or I can use long side, short side angle because Pythagorean theorem. Or, as some of you did, you marked angles R and T. Because the triangle RQT is isosceles. And if I have an isosceles triangle, the big triangle is isosceles, angles R and T have to be the same measurement. So the triangles are congruent for a lot of reasons, and that would be what QTS. So we can do hypotenuse leg, long side, short side angle. We can do what? Angle, angle, side. Those are the 3. So more than one option there.